With your knowledge on evaluating integrals using trigonometric substitution, we also have integrals yielding inverse circular functions. So for example, we are going to evaluate the integral of du over square root of a squared minus u squared, or integral of du over u squared plus a squared, or integral of du over u square root of u squared minus a squared. Observe that pwede natin kunin yung integrals ng mga ito by using trigonometric substitution. In the first integral, we may let u be equal to a sine theta. In the second integral, we will let u be equal to a tangent theta. And in the last integral, we will let u be equal to a secant theta. However, we have formulas for these special integrals para hindi na tayo mag-perform ng trigonometric substitution, which is medyo lang naman, medyo tedious siya. Ang challenge na lang ngayon is how to determine whether the given integrand can be transformed into one of these indicated forms. We have this theorem: for any a element of the set of positive real numbers, the integral of du over square root of a squared minus u squared is just equal to arcsine of u over a plus c. Tapos, yung integral naman of du over u squared plus a squared is equal to 1 over a arctangent of u over a plus c. And finally, the integral of du over u square root of u squared minus a squared, that is just equal to 1 over a arcsecant of u over a plus c. So, basta matransform natin yung ating integral into these forms, yung ganitong itsura, sure na tayo agad na eto yung kanyang mga integrals. So, for example, let's evaluate the integral of 2 over square root of 9 minus x squared dx. So, for our solution, we let now a be equal to 3 and u be equal to x. So, du here is equal to dx. So, okay, ilabas lang natin yung 2 kasi constant yan. So, we have 2 times the integral of dx over square root of 9 minus x squared. Or that is 2 times the integral of dx over the square root of 3 squared minus x squared. Since our x is just equal to u, so we have, now substituting itong mga nandito, we have 2 times the integral of our dx is just equal to du, square root of 3 squared minus u squared. So since ganito na yung kanyang itsura, we know that this one now is just equal to arcsine of u over a plus c. So that is now 2 times arcsine of our u is x, our a is 3. Now, let's evaluate the integral of e raised to x over square root of 1 minus e raised to 2x dx. So, in here, we let a be equal to 1 and our u be equal to e raised to x. Taking the derivative of u, we have du is equal to e raised to x dx. Gagawin lang natin siyang integral of e raised to x dx, yon, pinasok lang yung dx doon para magkasama sila, over the square root of 1 squared minus e raised to x squared. Diba? Pwede natin gawing e raised to x squared yan. Then, diba ito is just equal to du. So, we have du. Square root of 1 squared minus what is e raised to x? That is just u. And then, square that. So, since kamukha na niya ito, then we can now use this. Plug in na lang natin. We now have arcsine of e raised to x over 1 plus c. Now, let's evaluate the integral of dy over square root of 5 minus 9y squared. So, dito baka iniisip ninyo, hindi pwedeng gamitin kasi nga, hindi naman ito perfect square. Pero pwede pa rin. Meron pa rin namang square root yung 5, di ba? So, we let a to be square root of 5, our u be equal to 3y, and our du now is equal to 3 dy. So, that is now equal to the integral of dy over the square root of square root of 5 minus square of 3y. So, since 3 dy ito, wala naman tayong 3, so magdagdag tayo ng equivalent na 1. So, we have 1/3 times 3 dy over the square root of square root of 5 minus the square of 3y. Then, ilabas natin ngayon yung 1/3 para maging ganito na siya. So, since 3 dy is equal to du, and 3y is equal to u, then we have 1/3 times the integral of du over square root of square root of 5 minus u squared. So since kamukha na niya ito, then we now have 1/3 times arcsine of 3y over square root of 5 plus c, or kapag ni-rationalize natin yung square root of 5, that is just 1/3 arcsine of 3y square root of 5 over 5 plus c. Let's compute the area of the region bounded by the graph of f of x equals 1 over 1 plus 4x squared and the lines x equals 0, x equals 1/2, and y equals 0. So for our solution, i-visualize muna natin ano ba yung itsura ng ating graph. Diba? Ito yung kanyang itsura. So etong shaded part dito, ito yung hinahanap nating area. Diba napag-aralan natin in our previous lesson that this area here is just equal to the integral from 0 to 1/2 of 1 over 1 plus 4x squared dx. Observe that pwede siyang maging ganitong form para magamit natin yung theorem 1.b natin. So we will transform this into this form. Thus, we let a be equal to 1 and u be equal to 2x. So our du here is equal to 2 dx. Now, by substituting, we have integral of dx over 1 squared plus 2x squared. Or that is now, since 2 dx yung hinahanap nating du, so magdagdag tayo ng 1/2 times 2. Then, ilabas natin yung 1/2. We have 1/2 times the integral of 2 dx over 1 squared plus 2x squared. And since this is just equal to du, and this one is equal to u, then we have 1/2 times the integral from 0 to 1/2 of du over 1 squared plus u squared. So, kamukha na niya ito. Therefore, pwede na natin gamitin yung ating formula. So, that is now 1/2 times 1 over 1. Diba? 1 over a natin is 1 over 1. Arctangent of u is 2x over a is 1. All evaluated from 0 to 1/2. Or that is just equal to 1/2 arctangent of 2x evaluated from 0 to 1/2. So we now have 1/2 times arctangent of 1 minus arctangent of 0. Arctangent of 0 is just equal to 0. So we now have 1/2 times pi over 4 because this is pi over 4. Or that is pi over 8. So let's evaluate integral of dx over x squared minus 4x plus 13. So in this case, wala naman tayong squared plus squared. Pero, check natin, baka naman pwede natin siyang gawing ganong form using completing the square. So we transform x squared minus 4x plus 13 as, paano ba ito magiging perfect square? Para siyang, diba, x minus 2. So paano natin kukumpletuhin yung x minus 2 squared? Magdagdag tayo ng plus 4 minus 4. Kasi 0 lang yan. Para itong part na to, maging complete square na siya. So if we group that, we have x squared minus 4x plus 4 plus, magkasama naman yung 13 minus 4. And we know that this one now is just equal to x minus 2 squared. And this one is equal to 9, which is 3 squared. So we now have square of x minus 2 plus square of 3. So, rewriting, we now have integral of dx over x minus 2 squared plus 3 squared. So, we let now a be equal to 3. Our u is equal to x minus 2. And our du is equal to dx. Now, by substitution, dx is just equal to du. Then, we have x minus 2 is u squared plus 3 squared. So, kamukha na niya ito. So, pwede na natin gamitin ito. So, that is now equal to 1/3 arctangent of x minus 2 over 3 plus c. Remember that our u here is x minus 2 and our a is 3. Kaya naging ganito na siya. And finally, let's evaluate the integral of dx over 2x times square root of 4x squared minus 25. So, for our solution, we let a be equal to 5 and u be equal to 2x. Our du is equal to 2 dx. Ngayon, pwede natin siyang i-rewrite as dx over 2x square root of 2x squared minus 5 squared. So, ganito yung kanyang tsura. Now, since 2x yung ating du, kailangan magdagdag tayo ng 1/2 times 2. So, ilabas natin yung 1/2. We have 1/2 times the integral of 2 dx over 2x square root of 2x squared minus 5 squared. By substitution, we now have 2 dx is just equal to du. Then 2x is u, square root of u squared minus 5 squared. So since kamukha na niya ito, then we can now use this. So we now have 1/2 times 1/5 arcsecant 2x over 5 plus c, or that is 1 over 10 arcsecant of 2x over 5 plus c.